Okay, this is 12.1, day 2. So we're going to just have a short little lesson and you have lots of time to finish this in class again. So that's good. You're evaluating polynomial expressions. That word evaluate, you remember that word?
Yeah.
We did it, we've done it this year. When it comes to equations, we don't evaluate them. What do we do to equations? It's an S word. We solve them. We find the answer, what x would be, right? We can solve it. But when it comes to expressions, we cannot solve them because they're not equations, right? They're just an expression. But we can evaluate them, and what do we need to evaluate them? Like, if I give you this, x plus 2, what do I need to evaluate that? I need to know x. So if I tell you right now x is 5, then evaluate that. It is 7. But if I tell you x is 100, that is 102. Do you see x can be anything we choose it to be, right? But if I make this an equation, which we're not doing today, let me make it an equation. X plus 2 equals 99. Now, could you solve that for x?
Yes.
What is x?
97.
You see the difference? 97, because you subtracted 2 from both sides. Okay? So today we're simply going to start with evaluating an expression, finding the value. So they're going to have to give us what is x, right? And then we plug it in. Okay? We substitute a value for the variable, and then we simplify it. Okay, so let's, see. What is x cubed when x equals 4? Your expression is x cubed. Find the value when x equals 4. Okay, so I like to sing my little song. When x is 4, we just plug it in, right? Like a Glade air freshener, right? Plug it in. There it is, plugged in. 4 to the 3rd. And so if you were going to expand that, that would say, everyone, 4
times 4 times 4.
3 times. We have 3 factors of 4. 4 times 4 times 4 is 64. 64. Good. So you have now evaluated it. You found a value when x was 4. Good. Now, you don't need to write this example down. It's in your book, but you don't need to look at your book because I have it up here. If you are asked to evaluate a polynomial expression right now, you little wee baby algebra people, you are going to be handed a gift. You're going to be given the equation, the expression. Here is an expression. Now plug in a number. Here's a number for you to plug in. Isn't that nice? But you got to find those things in the words. You don't have to come up with this. And this is a very famous algebra expression. It is what happens when you throw anything or project anything or drop things even. So see, what shape is that when I'm throwing this ball at? Well, the ball is a sphere, but what shape is it? It is, what letter shape is that? U-shaped letter, right? And so it ends up forming a parabola. We talked about that earlier this year, right? And you're going to do a lot more of that next year. So this is a very famous equation. It's actually an expression here. Negative 16t squared plus vt plus s. But they actually give you everything filled in. So it says you hit a softball with an initial velocity of 80 feet per second. So look at the 80 is in the expression. The height of the softball after t seconds can be found using this polynomial. Find the height of the softball after 2 seconds. So t is the time it's been flying in the air, right? And so find the height after 2 seconds. So what do? Plug it in. We just plug in 2. And then step by step simplify your expression. Let me tell you that, what do you think that 2 is? 80 is the velocity that this person hits the ball off the bat. 80. What do you think the 2 is? Look at the size of that person. What do you think the 2 is? It's actually the height of the ball off the ground when she hits it. About 2 feet off the ball. Is that reasonable? Off the ground, I mean. Is that reasonable? Yes. So it's 2 feet off the ground. Boom. And then there's this negative piece of the expression. Negative 16 t squared. And so when you hit the ball, what is pulling on it? Why doesn't it go to outer space? Gravity. So negative 16 is your gravity, okay? That's what's working against the ball. 80 is actually working to send the ball pretty far, right? So in this case, they simply plugged in 2 seconds for their t, and then using the correct orders of operation, simplified and found that after 2 seconds, the ball is at 98 feet. So the ball is still traveling. I wonder how long it would take the ball to hit 0. How long do you think it would take?
8 seconds.
3 seconds? You think 1 second it'll be back down to Earth?
No.
Do you know, in
3.
algebra, you will know like that, how to figure that out. Isn't that cool? Using this very equation, you can figure it out. But we won't worry about that today. We will do this instead. We will find the height of the ball after 3 seconds. So everyone try it right now. After 3 seconds, here's your equation. There's gravity working on the ball. T is the number of seconds. So right there, this expression first and then substitute. Plus, this person hit the ball at 80 feet per second. There's that velocity. And plus, this person hit the ball when it was 2 feet off the ground. That doesn't change. The only thing we're changing now is the number of seconds. And Dylan, you actually thought it would hit the ground in 3 seconds, so here's your opportunity to find out. Where is that ball after 3 seconds? Have you found it, Chris? Okay, let's just substitute what we know real quick. Whoops, that should be 80 times 3 plus 2. And go ahead and work on that. What's your question, Chris? What is 3 squared? Well, Juliana, what does it say up here? We're following it step by step, like a little recipe. Okay, so 3 squared is 9. Negative 16 times 9 is here. And 80 times 3 is simply 8 times 3 with a 0. 240, good. Plus 2. And now, has anyone calculated 16 times 9? What is 10 times 9? 10 times 9? 90, and 6 times 9? 54. 90 plus 54? What? Negative 144, good. Plus 242. I'm using the associative property there, aren't I? Oh, and when we add that up, what do we have? 242 minus 144? 98. Wow. Dylan, what is happening? What? I see what you're saying. No. How could the ball be at 98? Did this ball fly to 98 feet and stay there for a whole second? Who can tell me what it did? But wait, at 2 seconds it was at 98 feet, and now at 3 seconds it's at 90 feet. So it went up, imagine. I mean, this is what happens, right? It goes up and it freezes for a whole second and then comes back, right? Right? Is that what we see every day? Like, watch my ball. Is it freezing for a whole second? Did it freeze for a whole second? Everybody look closely. Did it freeze? Yes. For a whole second? Wait, okay, Rachel, when you say a second, you gotta say 1001. It has to be frozen for 1001. Ready?
1001.
That was moving. That was moving. So what is happening? Come on, somebody, use your brain. What is happening? Who plays baseball? Come on, what's happening? What do you think, Wesley? What do you think? What do you think? Oh, it was like a line drive. He thinks it was like a line drive. He's showing his hand like a line drive. So who agrees with him? Line drive at 98?
I agree, Wesley.
No.
Was it a pop?
Emily, what do you think?
I think it went up and then it moved for a while. It fell.
And no. Okay, here's a little player with a little bat. And I don't know how to show it. Swinging, hitting the ball. There's a softball. And it goes up, 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 up. And it hits 98 feet. And it goes up, 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 up further.
Oh!
And it hits 98 feet again. Do you see that? Isn't that reality?
So Emily was right.
Yes. Emily, did you say that?
Yeah. That's what she
I thought you said it stayed at 98.
I said it was falling.
Okay, so that's what it did. No, feet. That was a mistake. 98 feet. Okay, so as we know, it went up, it passed 98 feet, it spent a whole second above 98 feet. So we will be able to find how high it flew next year too. Which I could show you now, but oh, come on, you know you'll love it. You know it. There you go. What more could you ever want than to know that?